Calculus is one of the hardest part of mathematics. It is a real pain for almost all college students. This presentation would teach you a basic topic about calculus, the limits and its theorems. This also intends to make solving limits easier. What are limits? Limits are used to describe the value of the function at a certain input in terms of its values at nearby input. Limits also replaced infinitesimals in the 19th century.
Tabular approach is a method for trying some test values for x which get closer and closer to where x approaches from both left and right side.
So let's say we have this rational function here. We've got f of x equals x cubed minus 1 over x minus 1. And we wanted to take a look at what was going on around x equals 1. But what we're going to do to investigate that is to make a table of values of x and then our function of values. And again, we're looking around x equals 1, so we're going to put 1 in the middle, and then maybe let's look at 3 values on the left and 3 values on the right. And we like to get really close to 1, so that's why we started off with 0.9, and we can get closer with 0.99 and even closer with 0.99. The same thing as this. If we wanted to, we could add more values between 0.99 and 1, but this will suffice. And now, the way we find the function values is we just substitute. And we will use our calculator for this. You're going to get values that looks like this. These are all rounded. Here at 1, we know that this value is undefined, but we're not so concerned with what is happening at x is equal to 1. It's what happens as x gets closer to 1. So here as x is getting closer and closer to 1, it looks like f of x is getting closer and closer to 3. Same thing from the other direction. Well, that's what we call a limit. So we can say that the limit as x approaches 1 of f of x is 3. So the limit of f of x as x approaches 1 is 3. And the way we will write that is limit as x approaches 1 of f of x is equal to 3.
As you substitute 2 in your function, you will get 0 over 0. So that we will choose values of x that get closer to x is equals to 2 and plug these values into your function. To get to f of x, substitute your x value into your function. Or you can also use the calculator. Just enter x squared plus 4x minus 12 over x squared minus 2x. Press the calc equals your x value 2.5 and you will get 3.4. Same as 2.1, you will get 3.86. On the left side, we have an x value of 1.5. Substitute into the function and you will get 5.0. Also, in 1.9, you will get 4.60. 1.99, you will get 4.02. 1.999, you will get 4. 1.9999, you will get 4.
The graphical approach. The graphical approach method is another way of analyzing and identifying the limit of a given function. So for the first example, let us find the limit of f of x as x approaches to 2. To find the limit, let us first identify the limit of f of x as x approaches to 2 from the positive side. So we can see in the given graph that as we approach to the x value of 2 from the positive side, notice that the y value is 2. Therefore, the limit of f of x as x approaches to positive 2 from the positive side is 2. Then, let us identify the limit of f of x as x approaches to 2 from the negative side. So, we can see here that as we approach the x value of 2 from the negative side, the y value is also 2. Therefore, the limit of f of x as x approaches to 2 from the negative side is also 2. When the limit of f of x from the positive side and the negative side is equal, therefore, the equal value is the limit of the given function as x approaches to 2. So for our next example, let us find the limit of 2 divided by x minus 2 as x approaches to 1. So the limit of 2 divided by x minus 2 as x approaches to 1 from the positive side is undefined. This is because in the given graph, the line from the positive side didn't touch the x value of 1. So the answer will be undefined. Then the limit of 2 divided by x minus 2 as x approaches to 1 from the negative side is negative 1. Because the line from the negative side as it approaches to the x value of 1 has the y value of negative 1. Therefore, the answer will be negative 1. So we can see that the two answers are not equal. So the result will be the limit of 2 divided by x minus 2 as x approaches to 1 does not exist.
We're going to be talking about how to find the limits and the values of the function at various points on the crazy graph like this one. And I like to call them crazy graphs because I don't know of a better name for them, but it's really just an exercise in understanding the definition of a limit and how that can be different from the value of a function. So basically, in these kinds of problems, you're given a graph like this one. It's a totally absurd graph, and it's the graph of a function. In this case, we'll call it f of x. So this is the function, and we're going to be asked to find the limit of this function at various points and also the value of the function at various points. So we'll just go through each one of these and talk about what it means to find the limit of each of these values. So the first one, we're asked to find the limit as x approaches negative 1 of the function f of x. So we need to find the limit of the function as x gets really close to negative 1. So when we say x gets really close to negative 1, what we want to do is find the point at which x is equal to negative 1. So that's just this point right here along the x-axis. This is equals negative 1, and everything along this vertical line right here is x equals to negative 1. So we're interested in the limit of the function as x gets really close to this value. Well, you can see just intuitively that we're probably gonna have two options for the limit as the function as x gets close to negative 1, this hollow circle right here or this filled-in circle right here. But when you're asked to find the limit of a function at any point, really what you want to do is look for the continuous part of the function. Imagine that you're tracing your finger or running your pencil along the graph of the function. So if you start all the way over here at the left-hand side and you're just running your finger along the graph like this, and you get close to the point x equals negative 1, you're getting close to this line here, x equals negative 1. And no matter which direction you approach, from the left-hand side here or from the right-hand side, this way, if you trace your finger along the graph, when you get close to x equals negative 1, you're right at this point right here. And if we come across along to the y-axis, we consider that this point y equals negative 2, which means the limit of the function at that point is going to be y. For our second problem, we have limit as x approaches 1 from the positive side. And don't be confused with this one and with negative 1 and having this one with an exponent of the sign positive and here negative. This just means that as as x approaches 1 from the positive side or from the right hand side, from here, this is the positive side of x, of the x-axis, and as x approaches 1 from the negative side or from the left hand side, that's gonna be from here, the negative side of the x-axis. So we're gonna trace this one from the right hand side, from 1 here going there. This is 1, our positive 1, so the answer would be positive 3. For our third question, the limit as x approaches 1 from the left hand side or the negative side, we're gonna trace it from here, the 1, so it's going to be 2. So let's go to our fourth problem, limit as x gets close to 2 of the function f of x will, well, if we find the point x equals 2, that's right here along the x-axis, which means this vertical line here that passes through this point is x equals 2. Well, the graph there is just this point right here. There's nothing interesting or different happening at this point. The reason they throw this in here is just to remind you that if the function is normal, it's continuous in this area, there's nothing happening from the limit of the function. It's just going to be the y value at that point, and the y value here is y is equals to 2. So the function limit of the function is 2.
The limit laws. Evaluating limits can also be done analytically using theorems or limit laws. In this lesson, we will cover these laws and determine how limits for combinations of functions in the form of sum, difference, product, quotient, powers, and radicals are obtained. Theorem 1, where a and c are real numbers and n is an integer. Limit of a as x is approaching to c is equals to a. Limit of x as x is approaching to c is equals to c. Limit of ax as x is approaching to c is equals to the product of a and c. Limit of x raised to n as x is approaching to c is equals to c raised to n. Example. Limit of 20 as x is approaching to 2 is equals to 20. Limit of 10x as x is approaching to c is equals to 10 times 3 is equals to 30. Limit of 5 raised to x as x is approaching to c is equals to 5 raised to 3 and is equals to 125. Theorem 2. Limit of a constant multiple. If a is any constant and limit of f of x as x is approaching to c is equals to L, then limit of f of x as x is approaching to c is equals to AL. Example. If limit of f of x equals to 7 and limit of g of x equals to 1 over 4, then limit 3 f of x equals to 3 times 7 is equals to 28. And limit 8 g of x is equals to 8 times 1 over 4 is equals to 2. Theorem 3. Limit of a sum and difference. If limit of f of x is equals to L and limit of g of x equals to m, then limit of f of x plus limit of g of x equals to L plus m. Example. If limit of f of x is equals to 10 and limit of g of x equals to 8, limit of f of x plus g of x equals to limit of f of x plus limit of g of x is equals to 10 plus 8 or 18. Limit of f of x minus g of x is equals to limit of f of x minus limit of g of x equals to 10 minus 8 is equals to 2. Theorem 4. Limit of a product. If limit of f of x equals to L and limit of g of x equals to m, then limit of f of x times g of x is equals to Lm. Example. If limit of f of x is equals to 5 and limit of g of x equals to 20, limit of f of x times g of x is equals to 5 times 20, then is equals to 100. Theorem 5. Limit of a quotient. If limit of f of x equals to L and limit of g of x equals to m, then limit of f of x over g of x equals to limit of f of x over limit of g of x, and it's equals to L to m over m. If limit of f of x equals to 6 and limit of g of x equals to 20, we just substitute it into the equation. Limit of f of x over g of x. Limit of f of x over limit of g of x equals to 6 over 20, and just simplify, it's equals to 3 over 10. Theorem 6. Limit of a power. If n is any positive integer and limit of f of x equals to L, then limit of f of x raised to any number is equals to L raised to n. Example. Limit f of x equals to 2. Limit of f of x raised to 3 is equals to 2 over 3 is equals to 8. Theorem 7. Limit of a radical. If n is any positive integer and limit of f of x equals to L, then limit of square root of f of x equals to square root of L. Example. If limit of f of x equals to 49, then limit of f of x equals to square root of 49 is equals to 7.